Hi there. In today's episode, I'm going to show you how to web scrape the eBay website to collect valuable information about the real cost of the new RTX 3060 GPU from Nvidia. We are guaranteed to see inflated prices in the eBay website compared to the normal market, but the total uplift, the gap between the recommended retail price and the actual sale price that we see on eBay, will tell us a lot about the general health of the GPU market, especially taking into consideration that this is the first line of GPUs that have the new crypto mining ban. Consider also that eBay is one of the very few websites in the world where you actually can see historical data about what people buy and pay for. For this project, we're going to use Anaconda, Python, Selenium, BeautifulSoup, Pandas, and even Matplotlib to extract valuable information from eBay and visualize it in a meaningful way. So the first thing we're going to do is to start Anaconda. While we start Anaconda, just if you haven't heard of Anaconda before and you are interested in data science, this is a must because most data scientists actually use Anaconda. And the reason they use Anaconda is very simple. It comes with a preset of libraries which already are needed in the first place. For example, NumPy, JupyterLab, just to name a few. And also it gives you the benefit of creating isolated environments where we can just install the combination of libraries that we need without worrying about conflicts of versions. So without further ado, let's just create our new environment. Very simple, just to make it a bit short to the name. Okay. So now if we are creating a new environment, we'll be able to install some of the libraries that we need. So let's open the terminal, the command line in Windows. So one of the things I need to do to use the new environment I've created, I have to do conda activate RTX 3060 price tracker. Okay, so now I'm able to install libraries that I need. So the first thing I'm going to install is Pandas. Then I will need Selenium. Finally, I'm going to install the python-chromedriver binary, so I can use the Chrome driver to run Chrome. So I have main libraries installed. If I miss anything, I'll be able to do it later. So let's just set up JupyterLab. So I just click install. As you can see, it's very simple to get started. Can launch JupyterLab now. Okay. So here I should be able to start testing. Let's check if all the libraries that we need are there. So I'm going to first import Selenium WebDriver. So all good. Let's open a browser window and see if that works. Yeah, I missed an import. So I need to import the Chrome driver binary first. I should be able to open a window. Yes, it does open, yeah. So whenever you click a link automatically and the page is still loading, it might fail straight away. By calling the method implicitly wait, we can give a number of seconds of tolerance. So let's say if I put 10 here, it means that whenever you're trying to look for an element to click on or to check if an element is present, you will always wait up to 10 seconds before you fail. Because in the context of a website that is driven by JavaScript, quite often you'll see that the page is still being built after even you are able to see the first elements in the page. So you should always wait a little bit. The advantage of using this property here is that rather than always waiting 10 seconds every time, it will wait up to 10 seconds. So if the element is visible before that, then it will complete quicker. So the way I'm going to do this, I'm going to do a search on the eBay website and I'm going to select all the options I want. So I'm going to make sure I only see sold items. And then I'm going to just be careful here because I don't necessarily know. Look, for example, it has the RTX 3060 Ti and I don't want that in my search results. So I know the 3060 actually has 12 gigabytes of memory. So I'm going to click here in the 12 gigabytes property. I might be missing some data, to be honest, but for now, I think that's a risk I will take. So I have 3060 selected, 12 gigs of memory. I'm only displaying sold items, so I'm just going to copy and paste this URL. So I'm going to save it here. Okay, so next is to open this URL. To open the URL in the browser window that I opened earlier on, it's very simple. You just have to do webdriver.get URL. Okay, and let's see if it opened. And you can see here it has opened the window, but it does have these cookie permissions specified. So I need to basically click accept, but not manually. I need to actually write some code to accept this cookie. So I'm just going to inspect this element, and I can see here, I'll just use this. So I can see this button here is used to accept. So I'm just going to copy and paste this ID, and what I can do. So I'm going to look for this element and then click on it. So let's see if that works. It failed for some reason. The problem here seems to be that the element is available, but it's not clickable. So to solve that, I can just easily basically add a small delay just to give it more time before clicking on the actual button, because it seems like this is like one of the exceptions where this implicitly wait should work, but it seems like this method here only waits up to the point the element is present, but it doesn't mean that the element is clickable, right? So it might be present and not clickable, which is a rare issue, but it does happen, as you can see here. So it's good that you actually get to see this, because sometimes things don't work exactly as you planned them to be. So let's try and see if this fix works. So let's try this again. Okay, so now the cookie acceptance message is gone. What's next? So I'm just going to get the page source. Then I'm going to start using BeautifulSoup, which now I remember, I think I didn't install it, but let's just let it fail first. So let's see. There's no library called BeautifulSoup, so let's install that. Install BeautifulSoup. Actually, it's not BeautifulSoup, it's BS4, that's the actual name. Okay, so now it should work, the import. And then we just start BeautifulSoup and we give it the page source so we can basically inspect what the contents of the page are. Okay, so first thing I want to do is get the list of search results, but not the whole page. It's just the things I want to parse. So I can see here, this UL is going to be what I need. So I'm just going to copy this element here. So with soup, I can just get this element quite easily. So I'm just going to do soup.find. I know it's a UL, then I pass in a selector here. So class, and then the class is, let's just see what we get. Missing I didn't close the brackets here. So you can see there's a lot of text that's coming out. So I can already see something, but of course this is not in a format that I can use it for anything really. But it's a starting point. What I really want is to get from within these search results, I want to get all the LI items, basically process each one. So let's see. Okay, so I already have results, and then I just want to find all the LI items inside. So I'm just going to do find all, so it gives me more than one, if it has any more than one. And then I specify a selector. In this case, let's see what we can use. You can use the class s-item. But you know, you don't necessarily have to specify the selector. So let's do that, because we are trying to search within these search results. So you should only get what's inside. Okay, so you can see there's a lot of stuff here, all the L items inside. So let's try and process items equal to results. So I'll just copy and paste. Okay, then I just go for each item in items, and then we can just do item.text and see what we get. I need to print it, of course, and we can see all the text. Still not usable in any shape or form, but this is a starting point. So let's try and get only the items that we want. For instance, if I go back to the browser, I want the title, right? So I'm going to get the title. So the title seems to be inside this h3 with the class of sItemTitle. So let's try and do that. So item dot. So I only want one, yeah? So I'm going to use find instead of findAll. So it will find one. I'm going to specify h3 because it's the tag name. And to be honest, let's see what we get really. If we get more than what we want, we can always specify the CSS class. Right, so what we can see here is that not always what we want is shown. So sometimes it seems to be looking for an h3 class and it doesn't have one for whatever reason. And in that case, I think we can easily go around that problem by just adding an if statement. So if I say if title element, then print title. So any nuns that we had before, they've disappeared. Right now we are seeing HTML markup, so let me just put .text so we only see the text. And you can see already that we have titles that we want. Okay, that's good. Okay, we see some extra text here though. We don't necessarily want that. So you can see new listings coming up here. We don't really want to see new listing. So it seems that we have extra text that we don't want in our product titles, and so we need to clean this up. There's different ways in which I could do this, but I'm going to go with the simplest. As we can see here, each title has an h3 tag, and it also might have a span tag inside called new listing. So whenever we call the attribute .text, it will actually include this text if it's there. I could try and be much more specific to only just show this text without the one above. That's one way to go, or another way to quickly fix this problem is to remove this tag whenever we find it. So I'm going to go with that for now, right? And there will be other solutions for this. And it's just whatever it's the easiest, really. That's the thing that matters. Because we're just extracting data. We're not really trying to create beautiful code. So let's do this data cleanup in the easiest way. Inside the title element, I'm going to find a span tag. For now, I'm not going to include any class, but I could also check for this class. But it seems like it's only the span class that we won't get rid of, so it doesn't matter if it's what class it is. It should be good to remove. So if I do extract, it should remove it. Of course, I need to check first of all if this tag is present, and then I need to call extract if it's present. So I'm going to call it new listing tag, just to make it more meaningful, equal to title element. I'll just copy and paste this, okay? And then, so if new listing tag is there, then I just call new listing tag dot extract. In this way, it will remove the string, and then the title itself should no longer have the unwanted string. So let's try that now, right? So that went well. So as you can see, the titles now only include whatever is in the title tag, yeah? So without any tags from eBay. Okay, now the next thing to do is to extract the price. So let's see what the price is. So let's try and get the price now. The price is inside this span class s-item_price. So I'm going to copy this tag. This is actually a span inside item detail. So I'm going to use the class in this case. Just add it here. So price element equal to item.find span, and then I use a selector class. The selector will be the one I copied just now. So let's do an if statement as well. So if price element, then print. Okay. So now I'm printing also the prices, and you can see that we get the prices. No title here. I don't know what is the reason. Let me just double check in the page. Why do we have? Oh, I see. I have a bit of a problem. Sometimes you get a span class going through the whole of the title. That means I'm losing titles sometimes because they also have a span class. Not all the titles are inside a span class, as we can see here. So this is where it can get a little bit messy when you are dealing with scraping. It's not really that straightforward. So what I'm going to have to do is I'm going to make some assumptions about this data. So I'm going to assume that the new listing has this CSS class. So I'm going to change my code. So it doesn't just delete any span. It will delete only the one that has a particular CSS class. And this should work. You know, it really is all about the data we're seeing right now. So we can see light. So I'm just going to reset this. I have to try and parse the page again, because otherwise it's already missing the titles. That is one of the disadvantages of using extract. I need to run this again. So let's see if now we should have no gaps. So we have title and a price, which is great. The next thing I want is a date, so we can create some plots and sort it by time. So I can see here the end date. So I'm going to copy this CSS class. It should give me the date. So let's get date element equal to item.find. It's a span as well. Okay. So end date. And then we print it. Okay, so now we have a title, price, and a date. You will notice that it's missing the year. So later on, when I put this into a Panda, then we will have to figure this out. We need to add the year somehow. Okay, so we've now been able to extract all the information we want. The next step is to try and put this into a Pandas data frame so that we can actually do some data analysis on it. So I'm going to do that now. So to create a Panda data frame, I'm going to create a list of rows. First of all, I'm only going to create a row if I have a title, a price, and a data element, okay? So what I'm going to do is copy this code here. I'm going to create a new cell. Just going to modify this code so that if I have a title element and a price element and a data element, then I should be able to create a row to add to the Panda data frame. So I'm just going to do row equal to, oh, I made a mistake, I think I deleted too much. I need to keep this code here, okay? So we do the data cleanup here as we're supposed to. Then once we've done our data cleanup for this row, we just create a new row with title element, the data element dot text, title element dot text, and price element dot text. And then we append this row to the list of rows that we initialized outside of the loop. Once I have my list of rows extracted, then I can create a Panda data frame. So I'm going to import the Pandas library, and I'm going to call pd.dataframe.fromRecords. And then I pass in the rows, and then I need to pass in a list of columns. So first column will be purchase date, second column will be the title. We know it's all 3060, so it's not really a big deal right now. We don't have to do anything to the title for the time being. And then we have the third row is going to be the purchase price. I'm going to abbreviate it to price so it's easier for me to manipulate this. So this Panda data frame, it's going to be my data frame here, and I'm just going to print it then. I think I'm going to put this into a separate row so I don't necessarily need to repeat this all the time. So I'm going to run this once. Element not defined. It's a misspell typo, so it's just a lowercase l that I need to use. Okay, so now I have a list of rows. Let me just quickly check what's inside those rows. I seem to have much because it's not able to print everything, so it's giving me some useless output. Okay. So let's try here. Okay. Oh, I made a mistake, it seems. Oh, instead of appending row, I appended rows to itself, and that's why I was getting this strange result. So I need to correct that, so row. Unfortunately, that means also I need to reinitialize WD page source. I'm just going to include this here. And then soup equal to BeautifulSoup page source. Okay, so every time I call this, then it should always give me the same result. And now the list of rows should be correct. Okay, I was a bit confused. So now we can see our Panda data frame for the first page of results. This is only the first page. It's already in the shape or form that we want. Okay, so the next step, I want to transform this into a function, so that the idea is our Selenium script is going to go through each page and then click next until basically it runs out of pages. Let me go try to the end. And we know we've reached the end. The problem with this, it seems like if you click next, it keeps going. I don't know how many pages we have, but even though it's disabled, it still allows me to click it, which is a bit of a problem. So I need to check something. So it seems like if they disable this property here, it's set to true. Let's see what we can find out. So I'm going to create a method called get. Let's call it something meaningful. So let's call this. So convert page of the results page to Panda. So what we'll do is we basically just extract all the information from the page and we return it as a Panda. So I need to copy the code here and return it. Right, now I need to do a for loop which basically checks for this link here. It inspects to see if the link is actually enabled or disabled, because it seems like you can still click on it even when it's disabled. So I need to find out, because I don't want my script to be running forever. I want to be able to stop whenever it reaches the end of all the search results. So I need to get this link. I'm going to use WebDriver.findElement by class, and I pass in this pagination next. So find element by class name. So it seems like you found it. And then the question is how to get an attribute from this element. So I'm going to just get some page link. Then I just do next page link equal to get attribute. Pagination next. No, the name of the attribute is aria-label. That's actually the label itself. I don't want the label. I want this one, area-disabled. So you should tell me true or false. Okay, in this case it's true. That means there's no next page. If it was false, then it means I can keep clicking it. So I'll just convert this to a boolean by just doing a equality with true. Okay, so that should be easier to handle. First thing I do, I'm going to assume the URL is already loaded. I'll do this outside this method. So this method will take a page source. It will use BeautifulSoup. So it will instantiate the page source and create a soup object. And then results is going to be soup.find basically. I just need to copy the code that we had at the top. So find this. So this method should be self-sustainable. So what I'll do here, I'm going to create another method. So I'm going to basically take a URL with a query that you want to do on eBay. And what we'll do, we'll open that page. Okay. Then we will have to accept that the cookies. So do it here. This only happens the first time, so I need to think carefully about this. I'm going to create a boolean variable just to help. So I'm just going to put this here. If not, GDPR banner accepted, I'm going to click on it. It's only going to show up the first time. So that's why I'm doing this. So I need to put a sleep time here. So I'm going to wait for 2 seconds, in fact 5 seconds, before I try to click on this, to give enough time for the page to appear. Because what I found, if you basically try to accept this banner too quickly, the element is going to return you an error showing that basically fail, because the element might be in the page but not immediately visible or clickable. Okay, so once I've done that, I will reset this variable. Okay, it's a bit not very pretty, but you know, it should do the job. And now what we'll do is we'll extract the search results. So pass in the page source, and then this method will do what it needs to do. So I need to also have a loop, because there might be 10 pages of results. So I'm just going to do while loop. So I get the first list of results, then I check for the next link. Okay, so if is disabled, the next page, we break from the while loop, or else we basically continue. We click on that link. Yeah. Another thing I need to do here, and this is just to prevent my script from running too fast, and potentially eBay will challenge my script because it might think that I'm a bot. In that case, I'm just going to put a sleep of 5 seconds. Whenever I get search results, I'll wait 5 seconds before I go to the next page. It takes a bit longer, but in this way you don't get any unexpected errors. Okay, so I get the Panda data frame. For now, I'm just going to print the Panda data frame. I want to test this first to see if it works. So let's just play this. Then I'm going to get a new URL, use the URL we had at the top as a first test. I potentially could even extend this to basically allow me to do any random search, but I think it's safer to just use the URL that eBay generates for you. Okay. So I'm just going to call this and see what happens. It's probably going to fail, but at least I get some. So I have some errors. Not sure why it's complaining. So I'm just going to add this variable instead as part of the method. Okay, let's try it now. Seems like it's doing something now. You can see it's printing, it's extracting all the data correctly, and it should have finished by now. So it's completed. Okay, it did work. So I have created this variable here, GDPR, so that if we are doing this for the very first time, we'll set it to false, and then it will automatically accept the banner. So now actually in theory, I should be able to get any URL here, and I'll be able to collect the data for that URL. But for now, let's just focus on the 3060. Okay, I've created a Panda data frame, but I'm not really doing anything with it. So I want to return for each list of search results. First of all, I want to create a Panda data frame with all the search results. So I'm going to create an empty Panda data frame. I'm going to call it df total, and this will be empty at the beginning, but it will have some information. So it will have only the columns initialized. So I'm going to put columns equal to, I'm just going to use the same list of columns as this one here. Needs a list of columns. Okay. It's the end of search results, so that's why it actually didn't do anything. Luckily. We created an empty data frame with the 3 columns that we need. And what we need to do is, after we get a data frame for each search results, then we're going to have to concatenate this data frame to the total list of results that we already have. So I'm going to use pd.concat. I'm going to give it the total data frame, and I'm just going to add this data frame. It should give me a new data frame. Okay, so that should be it. Okay, let's try again. Another error. It is not defined. So misspelling. Let's try again. I'm missing one function here, so we are clicking too early. So it seems the next is not really working properly. Not sure why. And maybe it's by, I should do some XPATH here maybe. Let's see if this works. So I'm just trying to use XPATH instead of simply using class name, so I know exactly which element I'm getting. So it seems like it's working now. The only thing I haven't done here is actually return the data frame, so I need to do it again. Okay, so it's finished. So let's visualize our data frame. So we have 483 rows of data. That's good. Now with this code, I can just extract more information. For example, for the 3070. Actually, I can change this code. Remove this. Don't need to have this variable anymore, so I can just pass in a URL. For this to false. Actually, I don't even need to So I get rid of these two variables. I don't need them anymore. Makes things a lot easier. I can use basically this method to collect as much information as I want. I should probably add an extra column here just to specify the model. So what I can do. Okay, so now we have an extra column. Now that we have a nice method, I can just copy and paste this and collect information for other graphics cards. So let's build another URL. I will do that, and I'll see you again in the future. Almost 10,000 results for the RTX 3070. So it's just completed extracting all the cells of the RTX 3070. Let's just quickly take a look at the data frame that we got. We have almost 10,000 rows, plenty of info here. So I'm going to add the extra column as well. So we have an identifier to the 3070. So later on we're going to merge all these columns. We're going to merge all these data frames into one, so I need to have something that distinguishes each model. Yeah, so we have here the model, which we can use later on. So one more thing I need to do here, because it took quite a while to actually, especially for the 3070, we have almost 10,000 sales in eBay. So I'm going to save this into a CSV file so I don't lose it. So I'm going to use pandas dot, I think it's to CSV, and then I'm just going to call the actual data frame itself, and I'm just going to call it RTX-3070 eBay.csv. In theory, I should have a new CSV file. So I have a CSV file, we can see it here. Okay, so there's a lot of data there we don't want to lose or have to redo. Of course, there seems to be a case that I need to clean up the purchase date, but I can do that in one go later on. So let me do the same for the RTX 3060. So I'm going to save also the RTX 3060 into its own file. Okay, another file is created. Okay, so now I can also extract the 3080 and the 3090. So I'm going to do another search here. So let's do 3080. Memory should be around 10 gigabytes. It's not that many 3080s. So it seems like most of these graphic cards, they don't even have all the correct attribute set. Okay, we're good. So it seems like even though we might have some international items here, they all are converted to US dollars in this page. Okay, so I have another URL which I could use to collect 3080s. 200 items. So I'm going to take this URL and I'm going to search for 3080s. We just have to wait again. See you in the future. Alright, so we've already extracted the sales for RTX 3080. Let's save that into a CSV as well so we don't lose it. Let's do finally 3090. Seems like too much of a good deal, this one. I would say it's an outlier, but there is some surprising data here. Don't know how accurate it is. Okay, so but this is a good exercise to see if these some of these items here, they look clearly like outliers. I'm going to take them into the data and then we'll see what to do with it. So we now have the information about the 3090. Let's just quickly visualize the data frame. I have 4,870 rows. I need to add again the column that I forgot to add for the 3080. I'll add it in a sec. So let's do 3080 as well. 3080 and then 3090. So we do it in one go. Okay. Now should have a new column and the same for the 3080. Okay, so I'm going to create one big CSV file. I'm going to create one big data frame with all the different cells of 3060, 3070, 3080 and 3090. And then we can hopefully do some cool analysis of the data that we extracted. So maybe it's going to tell us something useful. I want to do first is actually just look. This is everything in one go. Okay, should be a list, I think. So, right. So now we have the data frame with everything in it. So we have a lot of data. Okay, so let's start analyzing just the 3060 alone. Now we'll come back to the whole data. I think everyone is concerned about the prices of the 3060, so we should just get some information from it. So I'm going to try and create a scatter plot, but you'll see that actually we're not really ready yet to do anything with this data, but I want to just show you what happens if I try to plot something straight away. Okay, so df.plot.scatter. So I'm going to try and create a scatter plot where on the x-axis it will be the date, the purchase date, and then on the y-axis it will be the price, the purchase price, and see what we get. Okay, this one. Okay, first of all we need to install matplotlib. Okay, so data frame, so df RTX 3060. Okay, you can see this is very odd, right? It's all broken, so you can ignore these results. You should be able to see purchase date here, but I have my browser in dark mode. Okay, so I've switched my browser back to the normal color settings, so it's easier to read, but you can see anyway that the problem I have here is this data doesn't make any sense. And the reason is quite simple actually. When we look at the data frames, it's quite clear that for example, the purchase date should be a datetime object and it's not, the price should be a float and it's not, and so on. So we need to basically fix all of this first. So let's start with the date, how to fix the date. Before I do anything, just notice that we are missing the year. We should add the year to the purchase date so we don't, it's a bit tricky because here we have some data that is for 2021 and some data that is for 2020. And really depends on the month. So we know that so far this year we've had January, February, March. And this data goes up to for the RTX 3060 is actually quite simple, right? The sales only started sometime in February, although this doesn't look like correct, right? I don't think this was on the 3060 unless we're missing something. But anyway, this is an outlier. But here it's very simple. I can just add the year 2021 quite easily. So I'm just going to add the prefix 2021 to all the dates. And now it should be okay. It's still not a datetime object, so I need to convert it now. I'll use a function to do that. So I'm going to use the toDateTime function. Then I'm going to pass in the column that I want to convert. And I'm going to pass in a format so I can explain. Basically, the function needs to know roughly how is this date itself structured. So I'm going to put the year. That's the first thing we have. Then we have a dash, and then we have %b. This is for the month in 3 letters format. Then we have the day, and then we pass in the hour and the month, and that should be it. So I need to save this to here. Okay. So you can see now that we have a datetime object, and if I do a scatter plot I should get better results now. Let's see what we get. Yeah, it's getting better, but as you probably have noticed on the left hand side we have too many values there. there's a few things I can do. Fix size, which allows me to control some of the sizes here. Make it a bit bigger so we can see more information. So our plot looks a bit better. Still not great. We have another problem. As you can see here, the price is still an object, which means it's just going to be treated as like a normal string. So we need to convert the price into a float. But before I can convert the price into a float, I need to get rid of the currency. So I can use the str function. If I do this, str.replace, I should be able to remove the $sign easily. But it doesn't just have a $sign, it also has comma. So I'm going to get rid of the comma as well. So let's see what we get with this. Some warnings, but it do what I wanted to do. I'll do one at a time. Now I don't have any commas and I don't have any currency symbols. And it's now safe to just replace the old column. And now let's take a look at the resulting data frame. So purchase date is a datetime object. Oh wait, I only converted the string, so I need to so I'm using the function s-type float. So now this is a proper float. And I can do some more stuff with it. So let's try and draw a scatter plot again. Let's see what we get. For some reason we have this data point, which is like, doesn't make any sense. There was nothing sold on the 5th of February, but it comes up as like an isolated data point. You can easily see it now, right? It really doesn't look right. So I'm going to get rid of it. It's row number 32. So the item, oh no wait, 32. So this item here, it's not what I wanted. Okay, so I've done a query to get the exact column that the RTX 3060 was launched on the 25th of February and this item was sold on the 3rd of February. This is not, it can't be real. So I'm going to assume it's not real anyway. So I'm going to remove it from the data. So this is the item I want to get rid of. So I'm just going to add an inverse clause that will only return items which are above that date. And then I'm going to overwrite the previous data frame. Okay, so now I should have no problems anymore with invalid data. So I don't have the 5th of February. So I removed this outlier. And let's do the scatter plot again. It should look a bit better. Okay, much better now. We're starting to be able to see the shape of the data and we can see more or less what's the more frequent value that everyone seems to be paying. I'll say around $800 plus. That's what it actually seems to be selling for. Remember, the MSRP is actually $329 US. So let's just do a, I mean, this scatter plot is not too bad, but we can do better with Plotly. I'm going to install Plotly. So the reason I did this test is just to check whether the actual Plotly would work, and it doesn't because I need to install an extension for JupyterLab. So I need to go back to the command prompt and install my extension. Oh, I need to install Node.js as well. Nice. Install GS first. Okay, so we have the extension installed. Might have to restart matplotlib. Okay, looking good. So the example plot I was trying to show earlier, it's working now, but this is not what I want to plot, of course. I want to plot the scatter plot above, but in a much better shape. I want to create a box plot. It's going to give me more information about the data. So let's do that. Okay, let's see what we get. So pixel. Okay, so we get a plot of a box plot. The median price is $825 US. Seems like someone managed to buy the graphics card for $350, but because this is an outlier, I would say this is something out there. And then we have some very outlier cases. Anyway, this gives us the box plot, but I wanted to see also the scatter of the points, so I'm going to include in this plot all the points, so we can see the distribution. So you can see here it's just one instance of 350, and then here, yes, we have more instances of very high prices. Someone really paid, well, believe it or not, $1,200 for a $329 US graphics card, and then most people paid between $700 and $900. And then let's add the MSRP price, which nobody seems to be getting, which is $329 US. Okay. So the MSRP line is here. So this is all the information we gather about the 3060, and now we can go and maybe create similar plots for the 3070, 3080 and 3090, and then I'll just show you the results. So see you in the future. Okay, so now I'm going to try and plot the same graphs for the 3070, 3080 and 3090, but I need to do a little bit of data cleanup, and it's going to be a bit more complicated than what I just did, because for the RTX 3060 all the items were, I know they have been bought in 2021, but for the RTX 3070, 3080 and 3090 they start actually in 2020, and we can actually see exactly how far. Let's take a look at our data frame for RTX 3070. You can see there is December here, but let's see how far in time it goes, how far back. So I'm just going to use the tail. I'm going to use tail, and I'm going to just check the last 10 items in this table. So I can see all of them are for December, which means I only have to worry about December as the year. So what I'm going to do now, a more complicated search and replace. I'm going to add 2021 for any item that is different from December, really, because then we have January, February, March. So for that, I'm going to use a Lambda function, and that's going to be cool. Purchase date. So basically, this is a function, takes a value x. So x is a value in this column. What I'm going to do, I'm going to return 2020 plus x if x starts with December. Otherwise, I'm just going to return 2021 plus x. Yeah, so simple enough. So let's see if this works. Right now I'm not actually changing anything. I'm just going to output the values of the column. So it seems like I misspelled something here. Okay, so it seems like my code worked. So now I have a way to correct this column, and I'm confident this code works. I'm just going to replace this column entirely. Okay, and now should have something that's good to go. Yeah, so now I have good data. And of course, I need to go through the whole, the same thing I've done for the 3060, which is basically I need to convert these columns to the right value. Not this one. You can see they also need to be converted, but I'll do that, and I'll see you again in the future. So more complications. I've been doing the data cleanup for all the sales of the 3070, and I found that there is a few instances of prices where they have, you know, basically prices which are not really prices, they are just ranges. So what I'm trying to do, I'm trying to delete them. Initially I thought it was just one, so I deleted that one instance, but then I saw another instance of another range. And since we are talking about 10,000 values, I really don't know for sure how many of these instances we have. So I ended up creating using a regular expression here. So what I'm doing in this line, I'm basically looking for instances of this. So \d is a digit. So if I find any one or more digits, you know, plus means at least one, with the decimal point. So I had to use a backslash here, and then another digit, one digit or more. As you can see here, you have, it's a format, basically a float to a float. And then what I'm actually doing, if I just show you this one, I wasted a bit of time trying to figure out this regular expression, but anyway, this can be used for the 3080 and 3090. So if I do equal to true, it will show me only instances where I have this format. But what I actually want to do, I want to do equal to false, so it shows me everything else, and then I can get rid of this value in the old data frame. So I'm just going to replace the contents of the data frame with everything that should be good to go. So I'm hoping that I don't find any more instances of weird data. So I'm going to try and convert again this to a float. So this column is giving more trouble than I thought it would. But that's the way it is when you're trying to clean up data, especially data that it's not really, it's manually entered sometimes. Look at this. So hopefully it should work now. Okay, it seems to have worked. It didn't really like it the way I did it, but it works. So let's see if our new column. So now we have a float for the price and the date for the purchase date, and then we can actually plot this as well. I'm just going to copy and paste. You can see there's some strange data still. Let's use plotly as well. So the MSRP for this card is $499. So weird that we have a few instances of prices below $499. I honestly don't believe that you can get a graphics card for less than this reference price. Some of this data, they are probably outliers, bad data we need to investigate, but I'm not going to do that now. But it gives you an idea exactly what, look, all the concentration of values here are around this is the real price of the RTX 3070. So we have a median value of $859 US. The most you pay for this card seems to be around the $1,200, and you have some instances where it goes way higher than that, but maybe they are, we would have to look at each instance to see what it is, but you know, it's not that many data points that are out of the range that you would expect. So MSRP is 500 pretty much. Yeah, so the medium value is 859. The lowest you can expect to pay is for 800. and the highest is around 999. And then we have some very odd edge cases here, which I don't know what really, can't really infer too much from that. So let's do the same thing for the 3080, and I'll see you again in the future. So after I've done all the transformation of the data, this is the plot I get for the 3080. As you can see, there's a lot of data for the last 3 months at least. You can see a big concentration here of data points. Using Plotly, it's easier to figure out what's going on. So we can see here the median price that people paid for this is, for this graphics card, seems to be almost, well, $1,350. The most you are likely to pay is $2,000 US, and the lowest is $740. You can see there are some very strange values here, but they are outliers, like 35K, and there's some really huge values which I very much doubt there would be just one graphics card. There must be something else included in those figures, but maybe miners buying like bulk number of graphics card in one go, who knows. You should really focus on the values here. So this is the value for the RTX 3080, and I'm going to do the same for the 3090. I've already cleaned up the data for the 3090. Let's take a quick look. I'll put these values later in the screen for you to just put briefly. So this is the scatter plot for the 3090. So the MSRP for the 3090 is $1,500. Let's use 3090, and we get our box plot here. So the median price $2,100. Should expect to pay, the lowest is $1,299. It's a bit surprising, to be honest. I think there's some values here which I would say they are bad data, so I would need to take a look again. I need to do more data cleanup based on these results. I wouldn't expect to see any graphics card being sold for less than the base value, especially at around $10 US. So that means I have some data there which is bad and I need to throw it away. But even though I have a lot of things that are, a lot of data points that are bad, you can still see that if you look at the median value, it's $2,100 that you would pay for the graphics card. The upper value would be $2,449, and of course you do have some edge cases here, like it needs further investigation really. But yeah, that's it. That's all I have for you today, and I hope you enjoyed this video. If you like this video, don't forget to click the like button, and if you want to watch more videos like this, don't forget to subscribe, and see you again soon. Happy coding!